Hi guys, welcome back to Core Java tutorial. This is the 12th video tutorial of Core Java. Today we are going to discuss about multithreading. So multithreading in Java is a process of executing multiple threads simultaneously. So a thread in Java is about executing lightweight subprocess. The smallest unit of processing is called as a thread. So there are two types of multitasking is available. One is called as multithreading, which we are going to discuss, and the other one is called as multiprocessing. So both are combinedly called as multitasking. So multitasking having two types of multitasking. One is thread-based multitasking, which is called as multithreading, and process-based multitasking, which is called as multiprocessing. The major difference, if you see, the thread-based communication will be very less memory it is required, and it is very fast. It can able to communicate thread to thread, and compared to the process. So if we have two different processes, suppose if they are communicating, if they are executing simultaneously, and if there is a requirement to communicate each processor one to one, and the cost of communication will be very high. You can see the high level picture about how actually the life cycle of a thread, and how actually these multi-processor and threads actually exist in operating system. Now we can see how in a single operating system how the process and the threads will be uh, placed, so that you can understand a better picture on it. Suppose this is in your OS, this is your operating system. So each operating system will have set of processors. Suppose this processor 1, this process 2, and this is process 3. So I'll be naming them as process 1, process 2, and this is process 3. So in operating system, these executing multiple processors, like we can take three different processor here in this example, and we can execute timer simultaneously. This is called as multiprocessing. So communication between multi-process is possible. Like a process 1 can able to communicate with process 2. So process 1 can able to communicate with process 2. Also process 2 can able to communicate with process 3, or process 3 can able to communicate with process 2. Either way. So bidirectional it is possible. So this is called as process communication, and this communication will be very expensive. So this requires more memory to communicate, and this requires more RAM to communicate, and a lot of space it is required to communicate. So these called as multi-processing, and these not we are going to cover in this tutorial. We're just covering multi-threading in this tutorial. So multi-threading is about executing multiple threads simultaneously. So where these threads are actually physically exist in the operating system, the place will be inside a process. Suppose this is a thread, this is another thread, this is another thread. So if you see in a process, there are three different threads are available. So these I will be naming as T1, T2, that's a thread 1 and thread 2, and this is thread 3. The same way, the same way like how we have threads in the processor 1, the same way the processor 2 also will have set of threads. There is no time number of threads restriction. So how many threads? Suppose processor 3 is having only one thread. So different processors will have set of threads. So in each processor, as we're seeing, like set of threads are there. So executing multiple threads, suppose T1, T2, and T3, if you want to execute time simultaneously, that is called as multi-threading. So the communication between threads also possible, like how we have for processors, the same way each thread can able to communicate each other. So suppose T1 can able to communicate with T2, and T2 can able to communicate with T3. It's not tracking. Same way T1 can able to communicate with T3. Also the same way vice versa in T1, T2 in P2 process. So these are threads can able to communicate. So if you see the process communication, right, this will be more expensive as we discussed. It requires more space and it requires more RAM to process the communication. But in terms of thread communication, it will be very fast and it requires very small memory, and the threads alive in within a processor. So they process alive within the operating system. So this is the big picture of how threads will located in operating system, and so this is how we can understand like how threads and processor will placed in operating system and how they will communicate. So now we are going to discuss about uh, multi-threading, not the multiprocessing. We are not going to discuss now, and we are discussing about multi-threading. Now we can see what is a thread. So as we discussed, thread is a uh, lightweight subprocess. As we are mentioning, now we can get the definition properly. Thread is a lightweight subprocess. It is a subprocess within a process. It is doing some part of operation. That is why it is calling a subprocess. The smallest unit of work it will do. So as part of process, so it will do some smallest unit of amount of work it will do. So this is the thread. So in Java, how to we can implement multi-threading and how to do that. For that, Java is implemented one class which is called as thread class. So this is the class which we are going to use in Java to achieve thread programming. So thread also having different constructors, and it have different methods. Suppose if you see the methods are like start. Start is a method within a thread to start a particular thread, or run is a method to execute the operations what you are supposed to execute. Suppose if thread is supposed to do some set of operations, you have to mention in the run method of the thread. So start is going to be just just starting an thread, like how you're starting your car or bike, how you're just starting it. So that's how you're just starting a thread. For that, start method will be using, and for running, run method will be used to execute the set of operations. Whatever the Java code you're going to write, you have to put it in run method. And there is a method called sleep. So sleep is a method which is used to keep your thread for wait for some time, like it is kind of putting the thread in a sleep. So you ask the thread to wait for some time, so you can pass any milliseconds as a parameter, so it will wait for those many milliseconds. And join is a method which is used to allow other threads to join in the current operation. Suppose T1 is executing currently, and T2 you want to join with the T2 before executing T1. You want to complete the T2 to be done, and T1 is going to be, suppose T1 executing 10 lines of statements, and it is there in the fifth line. in between you want to initiate T2 and you want to complete the T2, then that is called join. So don't worry about it, and we can get a different program for this, and there you can understand what actually join is doing. And these methods are clear, right? The start is for starting a thread, and run is for executing set of commands, like you whatever the code you're supposed to write. Sleep is used to make your thread to wait for some time instead of, it's kind of pause button. So there are different other methods are available. Is alive, so which is used to check whether the thread is still alive or not. Suppose once the run method execution is done, then the thread will be going to be completion will be done, and it going to be dead state, and we're just checking whether it is alive or not, whether the thread is still running or not, and you can able to prioritize. For that, it means if there are 3 threads available in process, right? T1, T2, T3, and if you want to prioritize the T3 to first priority, and these are critical operation you want to execute at some point of time, and you want to make it high priority, and for that we will be having methods like set priority. Set priority is used to set the priority of a thread, and if you want to see any thread priority, what it is exactly for now means, if there is a method called get priority. So if you want to look at any thread priority, so this is a method you'll be using for getting a priority of a particular thread. So these are all the standard methods we'll be using. There are other methods available like get name, set name, which is used to set a particular name for a thread, and yield method, and different methods are there. A stop method is there. If you want to stop any thread, so you can have stop method, which is used to stop a particular thread period of time. And so now you can understand is alive method, right? So there is a start method and the stop method. In between, if you want to check is alive, we'll check whether the thread is stopped already, or it is running. If it is running state, then it will return true. So if you want to interrupt, there is an interrupt method is there. You can interrupt it. The different methods are available. You can go through one by one. And so these about basic about multi-threading and what is thread within a operating system, and what is actually do, and these are all the methods we have in a thread class, which is in Java API. Now we can see what exactly the thread life cycle will be and how it looks like. So I'm just saving this to desktop. If required, we can open it, and in between we can see it. I'm saving in my desktop. What name we can give it? Threads. Just I'm giving thread. So I'm just creating a new Paint document which is demonstrating life cycle of a thread. So now we can see what is the actually life cycle of a thread and what all the operations. We have seen different methods right here. I'm just opening that image. So desktop. Yep. So here we are seeing like these diagram of showing like a process and the thread where it is actually placed. Now we can see what is the life cycle of a thread. So we have different set of methods, and we can see how actually thread will go in a flow. So thread method is actually starts with new. So thread will start with new. I'll draw in better way so that you can remember, and make sure guys that this will be the interview question, and you should remember all the diagrams whatever I'm trying. So if you draw this much in interviews, that will be more than enough for you. So I'll tell you one by one. So the first stage will be new. which is about a new thread which is just created, and the next stage will be runnable. The next stage will be means it is ready to run. Runnable is a state which mentioned ready to run. And third stage will be running, means it's currently executing some set of operations. So the other stage will be terminated. So these are all the four phases we have: new, runnable, running, and terminated. There is a other phase which is about non-runnable. So you can remember, or you can mention it as blocked by any reason. There are different reasons you have. You can able to block a thread, which is about, we can discuss it now. What is blocked and all. So the first stage will be new, and the second stage will be runnable. The third stage will be running, and the final stage will be terminated. Once the running is done, then it will go to the terminate method. So to make once your object is created with the thread class, once you created an object, then if you want to start a thread, what method we are going to use? We have seen already the picture. There are different methods we have available. Which method is sufficient? The start method. The start method is the one which is used to make new state to runnable state. So start method we are going to use for making thread runnable state. Then it comes to run method, and it is automatically it comes to running stage. So once you started the thread, right, immediately it will go to the run method by default. You don't need to specifically call run method. So it means run method will execute. Once done, it will automatically call stop method. So the only intention is you just need to create an object. Here where you will be creating a new object, like new thread of something you will be creating here. So these are, we will be creating an object. It's a general syntax I'm giving. So once you created an object, then it will actually new state. Once you call the method called start, which is about, the way to call this is thread object dot start. That's it. Once you started this, then it actually executes. It will go to the runnable stage, and once it goes to runnable stage, it will pick the run method, and it will comes to the running, and it will actually execute the run method. Then once it is done, then it will make a stop. Then what is the stop? It make it as terminated. And when this non-runnable state will come in between, suppose as we are checking here, right, in which scenario the non-runnable stage will come. So to make you remember, I'm just drawing this. As I mentioned, I'm very bad at drawing. Just for your remembering, I'm mentioning this. So when this non-runnable will execute, the possible ways are either you need to call sleep method, means from runnable to non-runnable it will go. There is other possibility which is from running to non-runnable also it will go. So there are different possibilities with the runnable, how it will go to non-runnable, which is using sleep method. So if you are calling a sleep method in between, suppose if once you started the thread, right? After that, if you call a sleep method, then it will go to non-runnable or blocked state. Or there are other methods available to make it non-runnable, which is about resume, notify. All these methods will be there for making runnable. I don't want to make you to uh, uh, confused by telling all the methods, and for now this will be the more than enough. So to make runnable to block, there is a method called sleep. If you call the sleep method, then it will go to non-runnable state. And from running state also, if you call the sleep method, right, then it will go to non-runnable. So there are two ways you can able to call making your thread to running to non-runnable, or you can call, there is a method called wait. Wait is a method. So if you want to make your thread to wait, then it will actually go to non-runnable. And if you want to make non-runnable to runnable, you can make it as either you need to sleep is done or notify. So the way to make, now I'll explain the whole thing one more time. So you just need to create a thread. Creating a thread is simply about thread is equal to new thread of something you will be creating, or you can give the name here, and that will come as new state of thread lifecycle. Once you created a thread, then you need to start a thread using thread object.start. Then it will go to the runnable state. Then by default it will pick the run method. It will actually go to run method. It will execute. So if you want to make your thread to non-runnable or blocked, there are two ways to do that. Either using sleep method or wait method. So that you can able to make your thread to wait or sleep. So these are two methods you can make thread to runnable to non-runnable. And if you want to make non-runnable, means if you want to release the lock, right? This is called as locking. And if you want to release the lock from non-runnable to running state, then you have to use sleep done. Means whatever the sleep method you call, it should be completed. That is one way. And for the other one, for wait, there is a method called notify and notify all. Either of one, if you call, then the lock will be released and it will go to the running state, regular state. So this will be the typical life cycle of a thread. Now we can see how to create an thread class. So as we here declare, like we just created using thread class, right? There are two ways to create thread object. One is so creating thread in Java. There are two ways to do that. One is by extending thread class the other one will be by implementing runnable interface. So there are two ways you can able to create a thread in your own by extending a thread class. This is the class you have to extend using extends keyword. And there is other way is about using runnable interface. You just need to implement that method and you can able to create a thread using implementing the runnable method. So as we discussed, the methods will be same. In either way you can do it, either extending a thread class or implementing a runnable method. The methods will be same. All these methods will be available in all possible ways of creating a thread. So for now, I'm just creating a thread using Eclipse. Let's go to the Eclipse and we can create our own thread. So for that, I'm just creating a package to make our thread programs available. Multithreading, correct? So here I'm creating a thread. So thread 1, I'm just declaring. It's a simple class. So as we discussed, there are two ways to create a thread. One is about by extending thread class. Now we can see that how to create a thread using extending a thread class. The way to do this is just extends thread. That's it. So the only method you have to do is override. You have to override the run method of. See, if you just click on here, so the run method is coming, which is from thread class. Suppose if I remove this, so if I remove this one, so if you just type run method, so you're getting run void method, which is a new method it is asking. It's not about the thread method. So only if you extend a thread class, then you're getting the thread methods. So I'm just extended a thread class and I'm trying to implement run method of thread class. So override method in thread, which is there in the thread class. I'm just doing overriding the thread method. For now, I'm just clearing all this content. I'm just writing this out for testing purpose, whether the thread is created or not, whether it is running or not. Thread is running. I'm just putting a message. Now we can test our example with the main method. So what is the way? I just need to create an object for this. So the only way to do this is t1.start. As we discussed in the diagram, in the life cycle diagram, we just need to create a thread that will comes to new state. Then we just need to start a thread. So to start a thread, I'm just doing the thread object.start. The same I'm doing in Eclipse. I'm just starting a thread. What will happen if you run this code? Then it will, once you start this code, right, then it will actually comes to runnable and it picks the run method by default. You don't need to call specifically. And once the run method is done, then it will call the stop method and it will terminate, which is about terminating a thread by calling a thread method, stop method. So we don't need to call these methods. It will, by default, it will take care of compiler. We don't need to call these methods. You just need to create an object for the thread and you just need to call a thread. That's it. It will execute run method by default. So here we're doing the same. We're just creating an object. We're just starting a thread class here. So we'll see. See, the thread is running. So it's simply picking run method and it is once it is done, it goes to the stop method. The thread is got terminated. So these are all the ways. This is the one way to create a thread. We can see the other way, which is about creating thread using by implementing runnable interface. We can see that now. I'm just writing thread 2. Here instead of extends thread, here we did extends threads, right? Instead of extends thread, I'm just implementing the runnable interface. The way to inherit an interface will be using implements keywords. And You can guess the code now. It is simply telling, as it is a interface, there is unimplemented method. You should implement it unimplemented. It is showing on compiler error saying you should implement it unimplemented. Either you can type run method, and you can do the same how we did for extending a thread. But in interfaces, it is a mandatory to making unimplemented method, which is about run method. So if you do this, then run method will come by default. So this is an abstract method in a runnable interface. We must override this method, and otherwise it will throw compilation errors. So if you see the syntax, both are same. I'm just extending a thread, I'm just overriding a method. Here I'm doing the same, like I'm just implementing that runnable interface and overriding run method. Here also we can put some message. I'm just clearing this message. I'll write different sort of maybe. Running thread from runnable. So that's it. I'm just creating a main method and instantiating this object. So here there is a minor difference. So here, as we are extending a thread class, we're just making that class itself, that class object and dot start. We're just doing this, right? For interface case, we have to do in this way. We cannot directly call obj.run. There is a way to do this. Is you have to create thread class, which is the default class from thread, which is t1. I'm doing it. New thread of. You have to give your runnable interface reference, and this is the way you have to start it. If you are working with runnable interface, this is the way you have to do this. And now you have to do start method. As simple as that. Now we're getting the output, the expected output, which is running a thread from runnable interface. So this is about creating threads in two ways. Either you can do it in as the diagram mentioned, by extending a thread class or by implementing interface. Make sure both are doing same, by extending a thread and by implementing a runnable interface. And we are just overriding run method in both the cases. But if you are in case of extending a thread, we just calling the method directly on the object. And in case of implementing runnable, we just making a thread class object, which is from java.lang.thread. We're just using the class. We're just bypassing our runnable interface object method, object parameter. Then we're just calling t1.start, which is about thread start method. We're just calling, and now the execution will continue. It is same as the thread1 class. So these are the two ways you can able to create. Please make sure these are the important topics to remember. Ways to create a thread, and you should write the Java code even in interviews. Now we can discuss about the topic called thread scheduler. So what is a thread scheduler? So in Java, thread scheduler is a part of JVM. So Java virtual machine we have, right? Within that, thread scheduler is a part of it, and it decides which thread should run. Suppose we have different threads over here. So we have different threads over here, and the thread scheduler will decide which thread should run first and which thread should run last out of all these threads. Even they're processing at the same time, and depends on the priority, it will actually pick. Suppose if T1 is having the highest priority, then it will execute first. If T3 is having highest priority, then it will pick it first. Depends on each processor. Like in processor 2, if the T2 is having highest priority, then it will actually execute first. This is the thread priority we can discuss in next slides. This is called as thread scheduling. So thread scheduling is nothing about executing threads, depends on their priority, and which is taking care of thread scheduler. There is a separate Java program, you can say, or separate job will be there, which is actually does this operation. So picking a particular thread and execute first and execute last, these things will be done by thread scheduler. So now we can see the sleep method, how it actually works. So we have seen start method and run method, and stop will be executing automatically once the run method is done. Now we can see the sleep method, how actually sleep will work. For that I'm just creating a new file, thread sleep demo. Here we can see how sleep method will works for us. In this one I'm just extending a thread class. And run method, I'm just overriding it. Here what I'm doing is, earlier we just print a message, right? Instead of that I'm just doing printing 5 elements, 1 2 3 4 5. I'm just printing. So I'm just writing main method. So if you see, it's just a normal thread class, which is I'm just created using thread extending thread class. I'm just overridden run method. Now I'm trying to create an object for that. I'm just starting it. Nothing different. You just expect 1 to 5 numbers. Here I can write 1 to 5 numbers, and it will be printed continuously. Nothing crazy output you can expect. It's just printing 1 2 3 4 5. So now we can see what sleep method will do. What I'm doing is, before printing this I'm just making thread dot sleep. What thread dot sleep is taking any millis means any milliseconds it is actually taking. It is a long value it is taking. I'll be giving some 500 or 1000. I'll be giving 1000 milliseconds. I'll be giving for executing threads. Sorry guys, some noise again. That's the reason I just paused the video for some time. So now we are actually testing a thread sleep method. So once you type your sleep method, then it is actually taking the exception it should handle. This is the compile time exception, as we seen earlier. So this is the checked exception it is asking. So either we need to try catch, we need to surrounding, or we have to throw it. For now I'm just surrounding with try catch. So nothing crazy code over here. It's a just calling sleep method. So the particular exception, you see how crazy, how good the Eclipse IDE is will be. Like, it is simply detecting the current error, exact error, and it is mentioning in a catch block interrupted exception. So for threads, if any exception is happening, if it is running state or something happening, if you are trying to break it or something, so interrupted exception is the one you have to remember for interview purpose also, so that you can mention this one to handle the thread related exceptions. So I'm just calling a sleep method for 1000 milliseconds. So we can see the output. So earlier we just printed the 1 2 3 4 5 without delay, right? We can see the output now, how it will print. I'm just running the Java application. 1 2, you can see the difference, right? It is printing time space it is taking. If I do increase the time more, right, then you can get to know more. You can understand how long it is taking to print each element. So this is the sleep method will do. It is actually pausing the thread for some period of time, and it is printing each and every element. So once the operation is done, once all the elements are printed, then it is calling a stop method, then it is going to termination state. So these are demonstration for sleep method. So if you want to pause the thread for some period of time, so you can able to do this way. Just need to call a sleep method out of it, and it will actually wait for some time, whatever the time you mentioned in the time with the sleep method, then it will wait for that time and it will continue executing your output. So these about this. And what will happen, suppose if I start a thread twice, suppose these are thread, what will happen if I start a thread for twice? I'm just increasing this time for mentioning this. Nothing different, it is just printing. What will happen if you start a thread twice? What will happen? We'll see it now. Not only this example, we can go to the first example, which is actually just printing a message which is about thread is running. Simply it is printing thread is running. Here we can test it. What will happen if I start a thread for twice? So the same start method I called for twice. What will happen is the first time it will actually start the thread, it will print the message whatever we have it in the run method. The second time it will actually throw an exception called as illegal thread state exception, because the thread is already started. So why you want to start it? We'll see it right now. See, the first time it is printed. The second time if you are starting, then immediately it is telling in fraction of seconds both the start will all go to the compiler, and it will actually check whether it is thread is started. Then it will throw the thread illegal thread state exception, because the thread is already started. So why you again starting the thread? This is the exception you will be getting if you try to start a thread for twice. So make sure you should call start method only once per thread. So then it will execute all the operation. Then it will print the messages whatever you expected, and it will execute the operations whatever you wrote in the run method. So make sure to call only once per thread. So what will happen if I do invoke run method directly? Suppose I'm doing the start here, right? So I'm just doing a start, as it is 2 times calling a run start method is not recommended. I just removed it and just calling 1 time, it is printed well. What will happen if you call a run method directly instead of start? Start, what I'm doing is I'm just calling run method. What will happen is you'll get the output same, there's no difference, but this doesn't work like the thread way, like the life cycle whatever we've seen, right? This doesn't go through this life cycle. It won't get started, it won't go to the running state, and you're not allowed to call these methods, sleep, wait and all methods. It won't go like this life cycle itself. This will behave as a simple Java class. If you're writing a method in a normal Java class, right? Like other Java classes whatever we wrote, as simple as that, it will just create this object, it will start it. To explain you more, for each method call, what will happen is, suppose if this is the main method you're calling, right? By default the compiler will call, right? What will happen is there is a call stack will be available in the memory. Suppose if this is your call stack, this is the stack memory. If you say for each and every method, this is the stack memory. What will happen is once you started this program, right, the main method, what are the main method you're writing, once you started this, there will be for each method call, one call stack will be created. For each method, one call stack will be created. Suppose if you're calling a main method, then main method is executed here. In this call stack, it will execute. So if you're doing in a standard way, like if you're creating a thread and if you're doing the start, what will happen is the start method also comes under the same call stack. Start method also will comes under same call stack. This is called as call stack. This is stack memory. For each and every method call will comes under each call stack. If you are doing standard way of declaring a thread, and if you're doing a standard way of calling, so then the start method will comes under same call stack. Even the run methods and stop methods all comes in the same call stack. If you're not doing in standard way, if you're just declaring like how we are doing here, instead of calling a start method, if you are doing a run method directly, what will happen is, for run method, it will create a new call stack which is not relevant to the main call stack. Here it will execute. Otherwise, the run method, start methods, run method and all, it will execute in the same call stack. It will make a new call stack in the stack memory. It will make a different call, which is as simple as the normal method call, which is nothing about thread server. So nothing thread lifecycle will involve. So this is not recommended to call run method directly. That is the reason we should call start method to make thread run method to be executed. These are only the standard way you have to do it. You cannot directly call. If you call it, there is no thread lifecycle will be involved in your program. Now we can see join method. So as we have other methods, like we covered run, sleep, and now we can see join method. What is the join method? How it actually works. For that, I'm just creating a new class, which is best join method. So what I'm doing is, I'm just extending a thread class here. As I mentioned, what join method will do is, suppose if thread 1 is executing, and if it is actually in progress, it is actually doing its operations, it is in progress, it is doing it is actually middle of the operation, and in between, if you want to start thread 2 and you want to make thread 2 to be completed before thread 1 to be completed. So in between, if you want some, I can say, if you are going for some temple, there will be like normal queue, and there will be some special queue, which is about the priority people, or the paid, the highest ticket people will be there. So what will happen is, for the for the same temple, to visit the god and to see the god, and for the same temple there are two different queues will be there. There will be normal queue and there will be reservation queue. So normal people will go, and they can go through the whole queues, and they'll go through, they'll do the darshan and all, right? Before that, what reservation people will do, they will actually join in between, they will complete their task, and they will go before the normal queue people will go. The same way is about same thing, like T1 is executing and it is in middle. So what T2 you're going to execute in between, T2 will join and it will finish this task, and it will actually come out of the execution. Then after that, the T1 will continue until the once T2 is done, then it will actually continue execute and it will actually done it. That is what join method will do. So you can simply remember reservations, like normal reservations in queue and special reservations in queue. They will join and they'll complete it, and they'll go first before the normal queue people are going. So that's the best example I can say. Now we can see in real time how the threads are working. So I'm just overriding run method over here. So what I'm doing is, simply I'm printing 5 numbers. So to make our understanding, I'm just making thread dot sleep for 1000 milliseconds, and as we need to surround with drive cache block, I'm just doing it. So I'm just calling a method. I'm just making 1000 milliseconds to make you to visible properly the output, how the output is rendering. So what I'm just creating a main method for you. In main method, what I'm doing is to make multiple threads, right? I'm just creating a 3 objects for thread. The way to do this is T1, T2, T3. So I just created new thread classes, which is about 3 threads. I just created. What I'm doing is I'm just starting 3 threads. T3.start. So I just started 3 threads. What I'm doing is, if you just execute this output, right, you can see the result, how it actually looks like, and we can modify the join method and all later. First, we can see the output, how actually 3 threads are resulting. What it is giving, randomly it is printing 3 threads, 3 zeros, 3 ones, 3 twos, 3 threes, 3 fours. To make you more understanding, I'm just making these numbers to 1 to 5 so that you can understand better. So for 3 threads I'm starting. What 3 threads it is actually printing numbers from 1 to 5. 1 1 2 2 3 3 4 4 5 5. So all the threads are starting same time, so that it is actually printing same results for us, right? What I want to do is, I just want to T1 to be completed or T2 to be completed, or any one of the thread to be completed, and just want to complete the T1 first, then I want to go for T2 and T3. The way to do this is, you just mention T1 dot join. So if you mention this is also required, like how sleep method is required. You just need to surround with, or either you need to throw the declaration or you need to surround with try catch. I'm just doing the try catch. So I'm just restricting compiler to execute my T1 first. Once it is done, then you'll go to T2 and T3. We'll see the output, what we can get it now. You can see the difference now. See, it is just printing first thread first, 1 2 3 4 5, because 1 is done, then the remaining threads are running. 1 1 2 2. This is about second and third thread output. This is about the first thread output. Getting me right? So it will actually start from first thread. Once it is done, we are mentioning make priority T1 and let it be done. After that, once it is done, then only you can execute other processors. That is the reason the first thread is starting. It is printing the outputs like 1 2 3 4 5 continuously. Once the thread is done, then it is going to the T2 and T3. Then it is executing 2 threads simultaneously. The previous output we got is like 3 ones and 3 twos, and likewise we got, right? Now we are actually making thread 1 to be completed first, and it will go for other threads later. So this is the way to make your threads to be joined, and you can able to prioritize your thread. Either of the thread you can do the same thing. Suppose if you want to T2, if you want to do, you can do the same thing for T2 or T3. The same thing. So this is about join method. Now we can see naming a thread. So if you see the base example, it is just a normal thread where it doesn't have any name. We can see what the thread name for this. After running, I just want to print what is the name for this. Name of this particular thread. For that, I'm just prefixing with name is, just printing what is the name of the current thread. The thread name is thread 0. It is giving, it's simply giving thread 0. So I don't want this default name to be available. I just want to, sorry guys, I just want to set my own name instead of using this by default name. I just want to set my own name. The way to do this is, you have to do it in set name. James thread. So I just renamed it. So I have set in some name instead of the default name thread 0. I have set it some name. It is, see, you can see the name is James thread. So make sure you have to do set name and all after the start method is done. Before the start method, it doesn't recognize as thread and just treat it as an object. So make sure after the start method is done, then you have to set the names for each thread. So you can set any name for the thread and it will actually occur as you mentioned in the name. So the same name you will be getting either way, wherever you want to access. So these are the way you can able to set the names for your threads. So as per our methods, like we have covered start method, run method, sleep, and names are not getting mentioned over here, so we have covered it even. So now we can see the priorities. What is the priority of a thread? As I mentioned, like thread scheduler will pick up the threads that depends on their priority. It will actually execute the threads. So even it is having one processor is having multiple threads, so it should decide which thread will go first and which thread will go last. So for that will happen depends on the thread priority. So the way to do this is I'll check the current thread priority. What is the current thread priority? For that I'm just commenting these lines to make better understanding. For now I'm just having only thread is running, nothing else I have. So I'm just having this thread. I just want to print the current priority. What is the current priority it is having? For that I'm doing sorry guys. So why can't I do this in thread method itself? When it is running, we can get to know the priority, right? Why should I run in the below? Here, when it is thread is running, here itself, I want to know like what is the priority of this thread. I will write it here itself. So what I'm doing is just writing my priority is, so the running thread priority will be, what is the priority? The way to do this is there is a method called thread dot current thread. Current thread is for the current running thread dot get priority. So these are method which is used to get your priority. The same way you can do here. My name is get name. So you can get the name of the thread and the priority of the thread. It is giving thread 0. If you just set this value, it is giving James thread. See, thread is running. Its name is James thread and its priority is 5. So there are different levels of priorities are available. There are the priorities will be, it is a 5 priority, it is a middle priority which is about the minimum priority is will be the 1 and this is the normal priority. Normal priority comes at middle of the element. So the thread priorities will be the ranges I'm telling. Ranges will be 1 to 10. Out of it, 1 will be the least priority. You can tell it as min priority. And 5 will be the normal priority. And 10 will be the max priority. So these are all the different priorities are available. You can set it any number of the priority. It doesn't matter, like any number of priority you can set it. So suppose if the current thread is having minimum priority, right? I just want to change the priority to the min priority or max priority for this. I don't want 5, I just want to give highest priority, which is first priority. If I want to give, I just give 1. The way to do this is, so make sure while setting the priority name, you can set after the start method. For setting the priority, you have to put it in before the start method. Just need to set the priority. So the way to do this is thread dot max priority. You can give the max priority, that's it. Then the expected value should be 10 in the console. See, now you got the max priority for the thread. The name is James thread and the priority will be the 10, which is max priority. You can, the same way you can give min priority. Min priority will be 1 and normal priority. So these are the 3 different priorities you have in the thread, and you can set it either one. By default, it's a normal priority. If you want, you can change it with min or max. That's it. So these are all the 3 different ways of setting thread priority for our thread class. Now we can see a very important topic, very important, which is about, I'll take a new slide. Daemon thread. So what is daemon thread? Daemon thread is a service provider thread that provides services to a user thread. So it's a life. It's again a thread. Suppose we have a different set of threads over here, right, in a diagram. So it is a similar to the thread, which is a service provider for which actually provides services to the user threads. So we can make either of one as a daemon thread. So if we have 3 threads over here, right? If I want to make T2 as a service provider thread, I'll make it. So the way to do this is, you just need to set a daemon thread as true. That's one of the property you can use it. And this is called as daemon thread. Daemon thread will provide services for all other user threads. So if you make T2 as a service provider thread, and how much this life will be until these other threads, suppose T1, T3 we have, right? Suppose this lifetime is 1 day and this lifetime is 3 days. So after 3 days, so which is the highest lifetime? This is having 3 days. So obviously this lifetime also will become 3 days, because if it's a service provider thread, this lifetime also become 3 days. So after 3 days, all the threads will be collapsed, and this thread also will be collapsed automatically, because there is no threads to be available to provide any services. So this is the daemon thread. If you make it, so this daemon thread life will be depends on the thread's life. How long the threads are alive, that much time these thread will alive. Once these threads are died or terminated, then automatically the daemon thread also will be terminated. You can see how to set a daemon thread in our class. It's a simple to do that, and even make sure these also to be done before your thread is starting. The way to do this is set daemon true. If you are making your thread as daemon, then it will become a service provider thread. Out of 3, it will become your service provider thread. This simple thing you can check it, or if you want to check it here, you can check it when the thread is running. See, you can have the different methods, is alive and is daemon. So is daemon, you can check it whether it is daemon or not. So for now I'm just commenting these methods to test our example now. So what I'm doing is I'm just putting daemon as thread. You can keep this output also. I just want to print that output alone. That is the reason I just commented the previous code. So what I'm doing is I've just created a thread class. I've just set it daemon as true. I'm just starting a thread. That's it. So it comes to run method and we'll see whether this if condition is succeeding or failing. See, it's printing. It's a daemon thread. You can try it in three different threads where we have. Suppose if we have three threads created in somewhere, right? I want to make to implement this example. I want to make three threads to be there, and I want to test it for one thread to set it as daemon. So in this case, we have three threads, right? Out of which I'll be setting two to as daemon, and I'm setting names for all of them. So here we just implemented for one thread. I'm just doing for three threads to implement this example. I'm doing that now. So I'm just setting T2 as set daemon true. So I'm making T2 as daemon. So I'm giving names to all the threads. T1 dot set name T1, T2 dot set name T2, T3 dot set name, just giving T3. So I'm just setting names for three threads, which is T1, T2, T3 as our variable names, and I'm just making T2 alone as daemon. So in run method, what I'm doing is if of thread dot current thread dot is daemon, just printing current thread dot get name plus printing is daemon. Printing for each thread whether it is daemon or not depends on it will print. If this is true, it will actually print. Here we are already checking whether it is daemon or not, and it's telling I am daemon thread. So if it is a daemon, just I'm printing the name of it and telling I'm a daemon thread. For other threads, I'll be printing I'm not a daemon. I'm not daemon thread. We'll see the output now, what we'll be getting. For that, before that, I'm just commenting this sys out or this for loop for our testing purpose. We don't need this now. This block also I'm just commenting. We don't need joins and all. So what I'm doing is I'm just simply creating three threads. I'm just setting one of the thread as daemon thread. I'm just starting three threads, T1, T1 start, T2 start, and T3 start. I'm setting names for them. And in the run method, I'm just checking which one is daemon thread, which one is not daemon. So out of three threads, what we have, I'm just making T2 as daemon thread, which is service provider thread. We'll see the result now. See, T2 is coming as it's a daemon thread, and T3 and T1 it's not a daemon thread, as we mentioned here. So now T2 will behave as service provider thread. This life will be until these T1 and T3 lives. So this is also alive. Once the T1 and T3 is stop working or terminating, then T2 also automatically terminates. So this is about daemon threads. Now we can see a very important topic, which is about thread pool. What is a thread pool? A thread pool represents a group of worker threads that are waiting for the job and reuse many times. It's a definition I can say. It's simply about suppose if I have database connection pooling and all, it will be the same concept. So there are threads will be created and it will be ready for you. And whenever the service is required, I'll be giving a thread for you, and you'll be using it, and you'll be returning to me again. That's called thread pooling. In general terms, I can say, suppose if you went to any movie which is a 3D movie, you'll be going and they'll be giving 3D sunglasses for you. What you will be doing, you'll be taking the number of classes are required. Suppose if you book 3 tickets and you'll be taking 3 sunglasses with them, and after watching that movie, then you'll be giving back to the theater people. So that is called as sunglasses pooling, I can say. So he is actually holding set of sunglasses and he will be distributing to you if you require. So again, you will be, once your work is done, then you will be giving back to the theater person. The same way, the threads will be created and it will be ready with the thread pool. And whenever it is required, from the thread pool, you can able to query and you can get the number of threads, how many you want. So once the job is done, the threads will be written back to the thread pool. It will be alive in the thread pool. So we can see the running example how to implement a thread pool in programming now. For that, we just need to go to Eclipse. I'll be closing all these. Just creating a thread pool class. Which is about, I'm just creating a class called worker thread. I'm making this worker thread to be, I'm implementing a different way. Instead of so far we implemented using by extending thread class, right? I'm just doing in a different way, which is implementing runnable. So what you have to do, if you are implementing this runnable, you should implement run method out of it. So before that, what I'm doing is I'm just having one more variable, which is about message. And I want this message to be allocated when the constructor is when the object is constructed. So that what I'm doing is this is not a pool class, and this is the thread class I'm using in pool class. So I have just created a thread class by implementing runnable. I'm just adding my own message out of it. I have overridden the run method. Now I can write some message within the run method. So I'm just printing the thread name. What will be the name of the thread? The way to do this is we just did that. Thread dot current thread dot get name. So this is a way of getting a name of the thread. Then what I'm doing is once the thread, this is starting, right? Once you start the method, so what I'm doing is once the thread is started, the message, what is the message we have? I'll be printing that message. Now the second step will be I just want to print end message as well. I'm just putting the same line of code so that I'm just replacing, copy pasting same thread. What will be the end message? Before printing start and end, I just want to execute some operation which is process message. What this process message will do, I can do set of operations here. Set of operations, you can put it. Maybe it might take 2 seconds or something. The set of operations I'll be putting. To making this to be wait for 2 seconds, I'm just using thread.sleep. You all know I'm just making 2 seconds to wait it. 200 milliseconds, 2000 milliseconds or 2 seconds. I'm just asking this process to be wait. That's it about my worker class. I'm just done with this, and I need to call this method in between the start and end of the messages. So what I'm doing is I just implemented a runnable class, runnable interface. I have overridden the run method. Before that, I just want to print a message when the thread is started, and before ending, I just want to print a message. And before that, I just want to process some operations, which is process message, which is actually taking 2000 milliseconds of the time. Now I'll be using a thread pool class, which is actually creating set of threads, and it will actually using the worker thread what I created. So I'm just creating thread pool demo. Here simply I just write main method. So remember guys, this is very important. To create set of threads in Java, there is a class called executors. Executors is a class which is used for creating n number of threads. If you want to create n number of threads, you can use the executor class to create that. The way to do this is executors to my English executors dot new fixed thread pool. So this is a method you can use it, and here you just need to mention n number of threads, how many threads you want to keep it in the pool. As I mentioned in the 3D theater, on there be keeping n number of 3D classes. The same way I'll be having n number of threads, which is about, I just mentioned 5 threads. So the return type for this executor service will be executor service. So this is a service which is actually used for creating my own thread pool. So this comes under java.util.concurrent. So executors and executor services are comes from java.util.concurrent package. So now what I'm doing is I'm just using my worker class, which is the worker thread I'll be using here. The way to do this is I'm just looping for 10 times. So as it is runnable implemented method, I cannot directly instantiate worker method. So I'm just doing a different way. Instead of, I cannot able to instantiate that method, because if I do that also, it won't behave as a thread. So what I'm doing is I'm creating worker instantiation. For that I'm doing new worker thread, and it is expecting a message. The message is nothing but I'm just giving I equal to 0. So it is a string. I cannot directly give it here as a parameter. If I give it, then it will show invalid data type. See, this constructor is expecting string and you're giving int. So to avoid that, I'm just giving appending string, so that then it will become as string value, or you can do this way, string dot value of, you can give it I. Either way you can do it. then it will convert it as string. So now I'm just using executor class. So this is the one which is used for execute of worker, on which thread you want to execute. So I'm initializing 10 threads out of it. I'm just creating a thread pool which is about fixed file size, and I'm just creating 10 times the threads, and I'm just running thread one by one. Now we can see, so our requirement is to run 10 threads at a time, and what pool will do, out of 5 threads it will actually give one thread one by one, and once job is done, the thread will go back to the pool, and again the second request, the thread will come to the worker. So once all the operations are done, what I have to do is executor dot shutdown. So once all the work is done, you have to shut down the executor. Means you have to, once the job is done, right? I'm just shutdowning the pool, and until the operations to be done, you have to wait, right? The way to do this is while of executor is terminated. So you have to wait till the executors to be terminated. Until it is not terminated, you just want to loop through it, and you just need to wait for it. Then this what which is mentioning like about all the threads operations are completed. Now I'll be printing done executing all the threads. Now I can directly run this application. I can explain you the output. See, you'll be seeing, as I mentioned, timeline, right? 2 seconds in the executor, which is about 200 milliseconds, 2000 milliseconds. That is why you will be responding the output in delay, and it is actually printing in this way. It is actually created 5-thread pool. It is picked for first time, and it is reused it again. It is reused it. It is again called to the pool. It is get the threads, and all the time, all the operations, all the 10 threads are done. Then it is actually come to the finished status. So first, what it will do is it will actually create a pool with the 5 threads. As we require 10 threads over here, for 10 times we are running a loop. So it is actually return pick a thread from a pool, and it will execute. It will pick from a thread, it will execute. Once execution is done, then it will actually return thread to the pool. So this is where the thread pool concept will be working in Java. Now we can see another important topic, which is about thread grouping. So what is a thread group? If you have a set of threads, if you want to group them as a, suppose if there are in class, if you take a class, there are 100 students are there. So it is difficult to manage a teacher to handle 100 students once. What teacher will do? She will actually group set of people in a group, and she will decide a group manager, and she can able to easily manage. The same concept is also comes under Java thread group also. It means that if you have a set of threads over here, suppose in processor 1 will be having 3 threads. So for now there are other 3 threads also there in the processor 1. So first T1, T2, T3 you want to group it, because these 3 particular threads are doing the same operation. So same set of same related operation, and you'll be grouping them as one. And you have different group within the processor 1. They'll be doing some other task. So the thread grouping will happen in Java. We can do it in programming now. How to do that in programmatically? So this will be the mostly useful concept in threads. Like thread grouping will be the most useful concept. Why? Because we can suppose there are a set of operations we have. For that we can create a separate thread group, and we can reuse them. Now we can see how it actually programmatically done. it's a simply, we can write it as, suppose if you have a thread, then you can directly run it as just implementing to runnable, just overriding run method. Here I'm printing name of the thread, nothing much. That's it I'm doing. And now I'm going to create a main method. This is actually creating a thread group. The way to creating a thread group is thread group. There is a class available. tg1 equal to new thread group of the name, any name you can give it. You can tell it as parent thread group. Now what I'm doing is I'm just instantiating this object. It's a runnable object, so I'm just creating object for that. So as we directly not start this thread, what I'm doing is I'm just creating a thread object for that. So usually what we are doing, just giving this syntax, that's it, right? We are doing. So these allowed, as we explained in the thread 2 example, we just need to implement the runnable, and we just need to create an object and then thread object variable, and we have to start the thread. So there is a other constructor available in the thread class, which is actually taking runnable implementation along with the target. Whatever the target is, it will actually take. Here in our case, I'll be giving T1, sorry, TG1 is a group for us, and runnable is the target. And this is one constructor we have. There is other constructor which is having, we can take thread group 1 and runnable along with the name for this particular thread. We can give name for each thread here itself. So we can do this way. What I'm doing is I'm just creating 3 threads for this same implementation. T2 with the same group, I'm just giving 2. So I'm giving thread name. So thread name will be listed over here for us. So T3 and 3. So what I'm doing is, once all is done, then what I'm doing is each thread I'm starting. T1 dot start. Once the configuration is done, I'm just starting it. This also T2 dot start. T3 also I'm just doing start. That's it. So after that, what I'm trying to bring is, what is the thread name? I'm just want to display the thread name, thread group name. So the same get method will, get name will be method is available for thread group as well. And finally, I'm listing what is the thread name and what is the list of the threads is available within the thread group. So this will actually print the list of threads available. So what I did was just implemented a runnable interface. I just created a run method out of it, and in run method I'm printing get name of the thread. Then I'm creating object for the thread, the runnable class. Then I'm creating a thread group. When creating a thread class, I'm just tagging to thread group. So all the 3 threads belongs to particular thread group, which is TG1. Now we can see the output. See, it is telling 1, 2, 3 are running. Thread group name is parent thread group, and the list of threads it is showing here, like it's an object it is showing. So these are, we can able to print the thread group details and the This object, if you get into the methods, all the methods, then you get more details about the thread group. That you can take it as assignment. You can go through it. So this is a way of creating thread group. You just make sure the syntax is. You just need to implement a runnable, and you just need to create an object for that, and you need to tag it to. While creating a thread object, you just need to tag it to thread group object, whatever is available. So this is the standard way of creating thread group in Java. So the other topic we are going to discuss about garbage collection. So this much about multi-threading, and we can discuss the enhanced advanced topics, which is about garbage collection. So just creating all this. Now we are going to discuss about. So what is garbage collection? Garbage collection is what if you have integer variables and different variables will be memory allocation is happening for each class. Once you declare any variable, suppose if you take any class out of our declarations, so any class, if you take any name string, if you declare, so this memory allocation will happen. And the garbage collection is the one which is actually looking into your classes. It is actually releasing the memories. So you will be assigning the memories, and once it is not used, the garbage collection will check the uses of the name variable, whether it is used or not. If it is not at all using, then it is actually does the garbage collection for us. The way to do this is, there are 3 different ways you can able to do garbage collection in Java on our own. If you want, you can do it in this space. The first way is by nullifying the object. I'll tell you how to do this. The way is, suppose if you have an employee, so these object you have, and you want to make this to be garbage collector. The simple way to do this is nullifying. It's nothing about equal to null. That's it. So this is the one way of doing garbage collection on our own. If you want to do the garbage collection, so this is the one way to do that. So if you do the nullifying, so automatically garbage collection will happen. This memory will be released. The other way will be by assigning reference to another. This is about suppose if you have same employee E1, new employee, and other object which is E2, which is new employee. So the way to do this is, if you just assign this E1 is equal to, if E2 is, if you don't want E2 to be available, and you just need to, if you don't want E1 to be available, sorry, if you don't E1 to be available, you don't want E1 again in future, so you just need to do E1 is equal to E2. If you do this, what will happen is, it will actually reassigns the value within the E1, and E2 will be free because you already assigned this value, right? It will be accessible through E1. So for that reason, garbage collection, what it will do, it will look for this value, and E2 is free because it is already assigned to E1, so it will be garbage collector. So this is the other way to do garbage collecting. The third way will be by anonymous object. So we have seen all anonymous implementations, right? In abstraction and uh, even in interface inner classes, we have seen how to create an anonymous classes. So instead of creating new employee to and assign it to even and all, if you do directly creating a method called, suppose if you have a method called get emp name in employee class. So instead of the standard way of doing is like we just need to create even and then we'll be calling as even dot get emp name we'll be doing, right? Emp name we'll be doing. So instead of doing this by creating an object under employee even is equal to new employee. So we'll be creating an object, then we are calling get emp name. Instead of doing all these things, you just need to call with anonymous reference. The way to do this is new employee dot get emp name. So if you did this, then it will actually, it won't, there's no memory allocation gap. So these how you can able to avoid the garbage collection and you can save the more memory. So once this, even this call is happen, the temporary memory allocation will happen in heap, and once it is the object is assigned, then the garbage collection will happen and the memory will be freed. So these are the three different ways you can able to do garbage collection, either by nullifying the reference or sorry guys, by assigning a reference to another or by anonymous object. These are the standard ways to do nullifying on your own if you want to do that. Sorry guys, there is a last topic we have to discuss. With this we can hold up this tutorial. That's about the class. There is a special class available in Java which is runtime. So runtime is a class which is used to interact with Java runtime environment. Not only that, you can able to access your own system resources, like if you want to notepad, if you want to open the notepad, and if you want to do something, these kind of operations you can do with the runtime class, which is actually interacting with your OS and the Java runtime environment. Both the things it will do. So I'll explain you the small example for this so that we can quit this tutorial. It's been a long so far. So we can explain you the runtime example. What and all we can do it with runtime, we'll see it here. Runtime test. So I'm simply writing main method. I'm just using runtime dot get runtime. This is actually returning the instance of runtime, and there are list of methods available. You can see one by one. exec, which is actually used for executing any command. If it is a Windows OS, you can give Windows commands. Suppose if you are giving I'll explain you something. So suppose if you have command prompt, if you just type notepad over here, what it is doing, it's just opening a notepad, correct? So I'll close this notepad as well so that it will be clear. So there is no notepads open in my console. I'm just typing notepad, just opening a notepad. So these kind of operations, these actually operating system is doing these operations. These commands will go to the operating system directly. So the same thing we can do it through runtime class. It depends on your voice. Either if it is a Windows, you can use runtime command, or if it is a Linux box, then you can editors you can able to open over there. The methods are like exec. We have add shutdown hook will be there. Suppose if you quitting your program anytime, suppose if you're quitting your program, if the program is running in command prompt, and if you want to quit the program using Control-C or something, by pressing Control-C, the program will terminate. And if you want to do some operations after the user clicks on Control-C or something, so for that case you will be using add shutdown hook. There you will be writing your block of code. and exec is used to execute set of commands, depends on the OS. Free memory will be used to free the memory of the runtime environment. And the garbage collection, you can able to call it, and that depends on the garbage collection, it will actually check the whole the memory allocations, it will actually try to free the memory. So these are all the different set of methods we have. We can go to the each and every method, and you can create a dashboard with this. Actually, you can create your own system dashboard. There you can see all the metrics of the operating system, what and all is there, and you can get the total memory and available memory and all, you will get it. So for now we can test with one of the most used command, which is exec. So as we just tested in command prompt by opening a notepad, the same thing we can do it here also, just implementing the same. So this is the exec. This is actually expecting a command. What are the command? You can pass it here. Before adding our command, we just need to handle an exception here. Either we should handle the exception using try catch or just throwing. I'm just throwing it for now. I don't want to handle it. So this is the expression you have to give. What command we gave in the command prompt, just a notepad. I'm just giving the same here. We'll see the output, what will happen. So the expected output will be, it should open a notepad for me, and I can able to type anything if I don't want. See, it just opened it. Just rerunning. Just executed it, and it is opened a notepad for me. So with this, you can able to run any commands. What are the commands you know in a Windows, and if your program is running in Linux box, there you can give Linux commands. With this, you can give execute your own commands. If there is some situations required, you need to execute set of batch files you need to call in servers, and these kind of things. You need to implement some sample Java files. Those places, those scenarios, you'll get to use these kind of classes for that. So these additional topic, I'm just giving it to you. So this will be helpful in your interview part. So thanks for watching. We can see the important topic, interesting topic in next tutorial. Thanks guys. Thanks for watching.